All right, this is a relatively, there are a few concepts here that are relatively difficult for some students, in my experience. So I think it's probably worth taking some notes and focusing on this. All right, so the topics today are equilibrium, elasticities, and allocative efficiency, market efficiency. Okay, so the concept of allocative efficiency is really important. It will continuously come back to us over the course of the first semester in microeconomics. Okay, and it's not as important next semester in macro, but in micro it's very important. So make sure you understand this concept. All right, so first of all, in a market, okay, you can think of the supply curve as being the marginal cost curve, as we talked about last time. Okay, it represents the marginal cost of producing each unit for businesses in the market. And you can think about the demand curve as being the marginal benefit curve. It's how much utility consumers derive from consuming the good. All right. At any price lower than the equilibrium price, which occurs at the intersection of supply and demand, the quantity demanded will be greater than the quantity supplied. So there'll be a shortage. And as a result of the shortage, consumers will bid the price up until it reaches equilibrium. Okay, so any price lower than P1 is going to cause consumers to bid against one another, and the price of the good will be bid up until the quantity supplied equals the quantity demanded here. Okay, and there's no longer a shortage. If the price is greater than P1, the quantity supplied will be greater than the quantity demanded, and you'll have a surplus. Okay, as a result of the surplus, businesses, in order to get rid of the surplus goods, would lower the price in order to sell all their output, bringing us again back to equilibrium. So the term equilibrium means sort of a state of rest. Okay, a point at which there's no tendency to change. Okay, you know that from your science classes. That's the same here. Any price other than P1, there's going to be a tendency to change. The price will either rise to get rid of a shortage or fall to eliminate a surplus. Okay, at P1, we have a state of rest, right? It's a stable equilibrium. All right, so that's the first piece. At equilibrium, we have maximized surplus, and so I'll explain what I mean by surplus here. When we've maximized surplus, we have an allocatively efficient outcome, which simply means that resources are allocated to the production of goods in a way that is best, sort of maximizes the welfare of consumers and producers in the market. All right, so now I want you to think about this a little bit, about these concepts. What the demand curve tells us is how much value consumers place on a good, how much they value a particular good. And you think about, like here with the first unit of output, the value that consumers, maybe let's just say this is like maybe $10, the value that consumers place on that good is what they would pay for that good is greater than the cost of producing the good. Okay, so the marginal benefit in this case, $10, is greater than the marginal cost of $2. What does that mean? Right, if you think about a world of two goods, rice and potatoes, okay? It means that, let's say this is the market for rice. For that first bushel of rice, consumers would pay $10 for that first bushel of rice. That's the value they place on the good. But what we give up when we produce that bushel of rice is $2 worth of potatoes. Okay, so this $2 number is an opportunity cost. By using resources to produce this first unit of rice, we have to give up some potatoes, right? And you have from production possibilities. The value of the potatoes that we are foregoing, what consumers would pay for the foregone potatoes, is $2. See? And so we would say we're better off producing rice, not potatoes, because the cost of producing potatoes is lower than the benefit of, the cost of producing the rice is lower than the benefit of producing rice. And so we would say we should produce that first unit of rice and forego that last unit of potatoes. Okay? Now, as you produce more rice, the marginal benefit reduces. And so that comes from the law of diminishing marginal utility, right? The more we consume of a good, the less value we place on the last unit consumed. And as we consume more rice, it also means we're consuming less potatoes. And so the marginal value of the foregone potatoes as we increase rice consumption is going up, right? So the opportunity cost of producing rice rises as we produce more rice. The marginal benefit, the utility from consuming that rice, falls as we produce more rice until at this point they are equal. The marginal benefit is equal to the marginal cost. Any amount of production less than Q1 would mean that the marginal benefit is greater than the marginal cost of producing that last unit, and we should produce more. Anything less than Q1 means there's an under-allocation of resources to the production of the good. We could add to consumer and producer welfare, consumer and producer surplus, by producing more. Okay? Anything greater than Q1 means that the cost, what we're giving up in terms of potatoes, is greater than the benefit, what we're getting from producing the rice. And that would also subtract from welfare. So any amount of output less than Q1 will give us less than the maximum amount of consumer and producer welfare. Anything greater than Q1 will give us something less than the maximum amount of producer and consumer welfare. And so we would say that Q1 is the efficient output. Okay, so when we are producing Q1 units of rice, we have an allocatively efficient outcome because this triangle of welfare, consumer surplus plus producer surplus, is maximized. Another way of explaining it is to say that at the last unit produced, the marginal cost is equal to the marginal benefit. So on a test, if I ask you, okay, is this an allocatively efficient outcome? Your answer in this case would be, if it's Q1, yes, because total surplus is maximized and the marginal cost of the last unit produced equals the marginal benefit of the last unit produced. Okay, that would be your answer. Let's quickly talk about surplus here. Okay, we would say that in a free market, both consumers and producers benefit. Okay, and let me explain how. Okay, so some consumers, as you can see from the demand curve, value this. Let's say this P1 is $5, so the equilibrium price is $5. What that means is that every unit sold is sold for $5. Okay, so we assume that the producer can't charge different people different prices. Okay, that he has to charge everybody the same price. So what that means is that there are some people who value the good and would pay more than $5, but they don't have to. So you can see with this first unit, whoever buys this first unit of output, this first unit of rice, pays $5, but would pay $10. Okay? And so we say that person gets $5 worth of consumer surplus. Okay, and that would be the case for every unit produced between 0 and Q1, making this triangle here, that area, equal to the dollar value of consumer surplus of all the goods produced in this market up to Q1. Okay, so CS here, this triangle, is your consumer surplus. It's the welfare that consumers get beyond the price of the good. Producers, as you can see from the supply curve, can produce the good up until Q1 for something less than $5. So for example, at the first unit, it cost them $2 to produce that unit, but they can sell it for $5. They make a $3 profit, $3 economic profit, and we call that producer surplus. This triangle below the equilibrium price is the area of producer surplus, the two together, make total surplus. When you produce at equilibrium, okay, that triangle is maximized. Anything less than Q1 obviously is going to reduce that triangle by some amount, the surplus in the market by some amount. Okay? One other thing, just as a test-taking thing, if I ask you to sort of define what I mean by equilibrium, you can say that equilibrium occurs at the point where quantity supplied equals quantity demanded. Okay? If we have a disequilibrium, quantity supplied will not equal quantity demanded. It would be either be greater than or less than quantity demanded. Okay, so that's allocative efficiency and equilibrium. The last topic is, how am I doing for time?
10 minutes and 20 seconds.
Okay, I'll try to wrap this up in 5 minutes. Okay, so the last topic is equilibrium. Excuse me, is elasticities. Sorry. Okay, so we'll focus on price elasticity of demand, which sometimes we abbreviate PED. So if I put PED on the board, I'm referring to price elasticity of demand. So what we're saying with price elasticity of demand, what it means is we're trying to determine the extent to which the quantity demanded of a good is sensitive to price. Do consumers stop buying the good when the price rises, or do they continue to buy the good when the price rises? Okay. So I got two goods on the board here: EpiPens and diamonds. We'd say diamonds are relatively elastic. We would say when the price rises, people will buy a lot less diamonds. Okay. So the quantity demanded of diamonds is very, very sensitive to price, to changes in price. And the reasons for this are, one, that it's a luxury. It's not a necessity. You don't have to, contrary to what I hear sometimes, you don't have to have diamonds, right? They're not something that if you don't have a diamond, you're not going to suffer ill health or something. You don't need them, right? Number one. And number two, again, contrary to what I hear a lot, there are a lot of substitutes for diamonds, okay? There are lots of other kinds of stones that you could purchase instead of a diamond, right? So, lots of substitutes and not a necessity. And so as a result, when the price goes up, people will buy something else, okay? So here you see the price rising from P1 to P2, and the quantity demanded falling a lot from Q1 to Q2. So there we would say that this good is relatively elastic. The quantity demanded is very sensitive to a change in price. Over here, like EpiPens have been in the news lately, right? The company that produces EpiPens has recently hiked the price of those EpiPens by a lot. People who use and need EpiPens, are they still going to buy them?
Yes.
Yeah, they have to, right? It's a necessity. It's as a matter of health, they have to buy those EpiPens. And so what will happen? They'll continue to buy the EpiPens, they'll pay more, and the consumption, the decrease in consumption will come out of something else, something they really don't need as much. And so the quantity demanded for EpiPens, for the same change in price from P1 to P2, the change in quantity demanded is very small. Okay, and so we would say that the price elasticity of demand for EpiPens is relatively inelastic. Okay? There are a number of ways to test whether a good is elastic or inelastic. Okay? If you use this equation, sometimes on a test, we'll give you the numbers, like the amount by which the price changes and the amount by which the quantity demanded changes. If you then just plug them into this equation, if the PED equals 1, that's a 1-for-1 change, a 1% increase in price would cause a 1% decrease in quantity demanded. We would say that that good is unit elastic. If the PED is greater than 1, a price change causes a big change in quantity demanded, we would say that good is elastic. And if the PED is less than 1, less than 1 but greater than 0, we would say that the good is inelastic. Okay, relatively inelastic. So that's one test. The other test is a total revenue test. Okay, so basically total revenue is what? The total amount that businesses make in the market, right? It's quantity, in this case it would be Q1 times P1, right? So total revenue is your quantity times your price, okay? Now, think about this. As the price of a good rises, what happens to its quantity? It goes down. So these are inversely related, price and quantity, right? Okay, so here's the thing. When the price, like here, when the price goes up, whether or not total revenue rises depends on which one of these is greater, right? If the percentage change in the quantity is greater than the percentage change in the price, then the total revenue in the market will fall, right? If this number here, the percentage change in this number is greater than the percentage change in this number, then this number will reduce, okay? And if this number, the percentage change in this is greater than the percentage change in the price, then we have what? A good that's relatively sensitive to price changes, or elastic, okay? So when the price change, in this case the price is going up, and the total revenue is doing what? Going down. When the price goes up and total revenue goes down, you know you have an elastic good. Okay? It would be the opposite. If the price goes up more than the quantity demanded goes down, then this number, the total revenue number, would rise. Okay? And you would have a situation where when the price goes up, the total revenue also goes up, then you know you have an inelastic good. Okay, that's called the total revenue test. Done.